All right, so my name is David Steele. I'm the senior architect at Crunchy Data Solutions, and I'm here to talk about doing backup with pgBackRest, particularly big backups. So here's our agenda. First, we're going to talk about why you back up. I hope I don't have to make too much of a case for that, but I might also introduce you to some new ideas and new ways you can use your backups. We'll talk about this idea of living backups, which is a way of integrating backups into your enterprise so that they are running all the time and being used all the time, and they'll be reliable and you can depend on them. Then we'll jump into design. Typically in the past, I've done some comparison between pgBackRest and other methods. I cut that out today a little bit to give us a little more time to talk about features, but we can talk about that maybe in the questions or afterwards if you have particular comparison questions. We'll talk about features, of course. We'll look a little bit at performance, and then we will have a demonstration. So the first question is, why backup? Like I said, I hope I don't have to make too much of a case here. There's the really obvious reasons why you back up. The first one is hardware failure. Right? The server itself just goes completely kaput. You need to replace it. And so you can use backups for that. You can also, this is a good case obviously for if you want to bring something up more quickly. Replication is another way to guard yourself against hardware failure. Shoot, hang on a second. I think this turned off. I'm not sure what happened. Anyway, I'll just go here. All right, so another thing you can use backups for is to bring up replicas, provide wall for replicas, in case they get behind with streaming replication, rather than trying to use wall keep segments or replication slots or things like that. If you just have an archive of wall, then the replicas can always go there and get it when they need it. And you don't have to worry about putting a lot of load on your master by storing a lot of wall there or worrying about the wall expiring, and then you have to resync your replicas and things like that. And the other thing, of course, is you'll be able to sync your replicas from, if you do need to resync a replica or bring up a new replica, you can do that from a backup instead of doing that from your master. Again, reducing load on your master. Backups can help you with corruption caused by either hardware or software, like your software. One of the biggest challenges with corruption is actually knowing that it's happened. If it's some kind of corruption going on in the Postgres backend or the file system, it may not be obvious. If it's something in your application, it may not be obvious. So the trick is to keep enough backups, hopefully, that if you do detect the corruption, you can go far enough back in time to do some recovery. But that's not exactly the topic of this talk, but it can be quite tricky. Another thing is accidents. So you accidentally drop a table or you drop it as part of an update. Maybe it was semi-intentional, but you really need to get that data back. Or someone deleted your most important account, right? And now you need to go back and get that data. So this is an area where replication doesn't really help you very much unless you have a replication delay. And even if you have a replication delay, it's a race against the clock, right? That stuff's going to get applied. You can turn off replication, but you don't really want to have to race against the clock like that. It's better if you can just have a reliable source of backup that you can go to and get the state of your database as it was a day ago, a week ago, if you're lucky and you had the space a month ago. Another area is development. So there's no more realistic data than production. So if you're in an environment and you don't have practical issues about size or privacy issues, HIPAA compliance, things like that, you can actually bring your production database, and even if you don't bring it into development, you can bring it into maybe a staging environment. And you can actually have replication going on there into a staging environment, take snapshots, do work, stuff like that. So there's a lot of great uses for development. Reporting. So one of the problems with replicas, of course, is they don't allow you to create temp tables and do other things like that. So a disconnected reporting server can work very well if you can work with slightly stale data. You can restore a backup into a server, bring it up as a master, do all your reporting, and the next day you repeat the cycle. Another thing you can do is, this one seems slightly out of place, but you can also recover important data that was removed on purpose. So some things were removed on purpose, it was intentional, but you realize later you want to go back and get back to that data. That should have actually been a major bullet point, I think, not under reporting. Whoops. All right, so I found this on the internet. I don't know who said it. I don't want to take credit for it myself, but this is so true. So it's true enough that I'm just going to go ahead and say it again. The state of any backup is unknown until a restore is attempted. So if you're doing backups and you're not doing restores, this is a serious problem. Because when you need the backup, there'll be a couple problems you'll face. And one of those is that the backup just may not work. There may have been some kind of problem, or you may not have been archiving, or you may have, BackRest does a lot of stuff to try to prevent you from making mistakes. But if you're not testing your backups, then you cannot rely on them. The other thing is you don't want, at the point where you're restoring a backup, so let's say the primary has gone down, the replica is no good, some other horrible thing has happened. If this is the first time you've ever attempted a restore, then that's a problem. No one's going to be comfortable with the process. So what you want to do is integrate the backup and restore system into your enterprise in a way that both operations are very comfortable for everybody. So when you get to the point where you need to restore, people know what to do, right? They've done it before. It's not an out of the way kind of activity where everyone's now nervous and scared, because then they're more likely to make a mistake on top of the already bad situation that you're in. So the trick is to find a way to use your backups in your enterprise other than for DR. DR may be the most important reason you have backups, but you need to find some other ways to integrate into the enterprise so that backup, restore, archiving, replicas, all this kind of stuff is a part of your daily business. So some suggestions are, syncing, creating new replicas. Of course, that's more of an admin utility. Offline reporting, offline data archiving. Let's say you have archiving requirements. You can actually use an offline server to dump that data and then truncate it in production. Again, reducing a load on production, the master server. For development, you name it, just something. Ideally, you actually have this life cycle where you're taking backups and you're restoring in them somewhere at least weekly. So maybe you sync up your reporting server every week, or you sync up your dev servers or your staging servers every week. So at the most, if things go wrong in your backup system, and the error isn't detected by whatever backup software you're using, hopefully at least you are finding out once a week that, oh wow, this backup doesn't restore. And if you've got a good backup cycle, then you've got a couple of older backups sitting around, and you know that you're always safe because you've got that older backup. Another thing is that, basically unused code paths aren't going to work when you need them. So this is kind of basically what I was saying before, but another thing you can do is regularly schedule failover, between your primary and replica, and then use your backups to restore the old primary to a replica and put that back on replication. Regularly scheduled disaster recovery. These are all things that you can do to make sure that your backups are working, your DR is working, and everything's in place. All right, so let's talk about some of the design decisions in pgBackRest. So one of the reasons why I started working on this software originally is I was working with very large databases in the neighborhood of 40 TB, Postgres. So, and we basically had this problem that, other backup solutions that were out there were based on tar, rsync, or some other single-threaded thing. And this simply was not fast enough. We also really needed things like destination compression. Rsync won't compress. It compresses in transit, but then it dumps it uncompressed at the destination. There are things you can do with ZFS and stuff to, make this problem better, but even so. So really, the design of BackRest was all about kind of like conquering some of these limitations. The main thing being that rsync is single process. It also has a 1-second timestamp resolution, which can cause your incrementals to not be reliable. If Postgres is modifying the file in the same second that rsync copies it, then the next time rsync goes to copy it, it won't see that it needs to be copied. Unless you do checksums, of course, but checksums are very expensive. The other thing is that if you're using rsync with linked dest, which is a common way to do incrementals, then the previous backup has to be uncompressed. So not only does your current backup have to be compressed, but whatever it's based on which could be a whole string of backups, incrementals all the way back to a full, also have to be uncompressed. So basically, the decision was BackRest doesn't use rsync tar, any of the other typical backup tools, command line tools, any of that. It basically implements its own custom protocol. It does compression, checksumming, size calculations, everything in stream. Nothing is ever done at rest. And it solves the timestamp resolution issue. It turns out this is really simple. All you have to do is wait the remainder of the current second. So you build the manifest, and then you wait the remainder of the current second, and that way if Postgres modifies any files, then they'll have a new timestamp. Simple as that. Time drift. Well, you can certainly have that if you've got time drift on your master, then that's going to be a problem with any kind of backup solution that's essentially time-based. So this is designed to deal with that one particular issue. Also, to some extent, things are a bit relative. So there may be time drift, but because I know I've waited till the next second, that unless you're actually drifting back a lot, then you should be relatively immune from that. If you don't trust that, then you can do checksums. So one of the big things that BackRest brings to the table is multi-process backup and restore. So usually in most backup solutions, compression is the bottleneck, right? That's the most expensive part. If you have a really slow internet connection or some other things like that, then that can be your bottleneck. But usually it's compression. So, but most Postgres backup solutions, as we've discussed, are single process. So basically, BackRest solves this with multiprocessing. That was, for a long time, that had been done with Perl threads. As of the last release, that has been converted fully to child processes for scalability. The problem is the Perl threads, they were only scaling well to about 10 parallel processes. And believe it or not, there are people out there running more than that, a lot more than that. So everything's been re-implemented with child processes, which makes basically most of the problem was spin lock contention in the Perl threading queues. So that contention has been removed, and that makes it quite a bit faster. So, on a fairly normal system using 8 threads, you can do about a terabyte an hour of raw throughput, which is pretty reasonable and doesn't put too much load on the system. You can do local remote operation without any strange configurations. So the protocol layer is designed to run through SSH, but you can back up locally. You can back up to an NFS server. You can have master and replica talking to an NFS server. Because of the protocol layer, there's no direct access to Postgres required. So all the start and stop backup and other commands to Postgres go through the protocol layer. So this enhances security. You don't have to have your Postgres port open. You only have to have SSH access. Full differential and incremental backup types are supported. And like I said earlier, BackRest is not susceptible to the time resolution issues of rsync. So the differential and incremental backups are actually safe to do. So there's backup rotation, of course, and archive expiration built in. Retention can be based on full or differential backups. Wall retention for all backups. So you can keep complete wall for all your backups in order to do point-in-time recovery. Or you can say, we really only want to be able to do point-in-time recovery from the last couple of backups. And for the older backups, the only wall that will be preserved is the wall that's required to make that backup consistent. Of course, you have to do that or there'd be no point in even keeping the backup. I don't really recommend this, but there are some people who generate so much wall per day, in the scale of terabytes, that because they just have such high turnaround, that they want to keep some older data for data mining and other emergency tasks, but they simply don't have the ability to keep all the wall. And like I said, so wall required for consistency is always preserved. You can never get rid of that, or you might as well just expire the backup. So the only time that wall will be expired is when the backup itself has been expired. And then that wall will go away because it doesn't serve any purpose anymore. There's a lot of attention given to backup integrity. So, I was talking about before how you really can't trust your backups unless you've been doing restores. But I've done as much work as I can to make sure that you can trust the backups. And if something goes wrong, then BackRest will notify you about it. So one thing it does is it calculates checksums, SHA-1 checksums for every file in the backup. And those are actually rechecked during a restore. So if anything's gone wrong in the repo, like let's say you've had data corruption in the repo, or someone went and just deleted a couple of files or something like that, you will find out about it, right? It won't just like silently restore a bad backup. It'll make sure all the files are there and that they all have the correct checksums and correct sizes, and if they don't, then the restore will fail. After the backup happens, BackRest will make sure that all the WAL required to make that backup consistent actually exists in the repo. So it'll just sit there and wait until archiving catches up, because sometimes it can be behind, but it will just sit there and patiently wait until all of your archive has arrived. It has a very simple backup format. So the actual backup directories are organized just like a Postgres cluster. Tablespace links are remapped internally so that they work. And so if you're doing, let's say if you're on a ZFS file system and you've turned off BackRest compression and you're using ZFS compression instead, what that means is you can take a snapshot of that cluster and bring it up in place. So for really big scale databases that it's hard to justify the hardware to restore them to, or the time involved would just be enormous, you can actually bring them up snapshot, bring them up in place. Obviously, you'll have to do replay, to a minimum point in time for consistency. But in any case, also, if something goes wrong with BackRest or something, or you have a system where you don't have BackRest, you can literally just copy the files over. And if it's gzip, you'll have to do a recursive ungzip. But other than that, the cluster is ready to go. So no magical backup formats. All operations do fsyncs at the directory and file level to make sure that everything is on disk. This is especially important for archiving. To make sure that the archive logs that you've told Postgres are actually, that BackRest tells Postgres are actually there, are really there. And you want to make sure that that's true. Another good feature is backup resume. So if a backup is killed, or it dies, or some other thing happens, it can actually be resumed from the point where it stopped. And the way that the BackRest does that is it periodically saves the manifest that contains all the files and all the checksums. So it will actually reload that manifest. Any files that didn't have checksums recorded will have to be recopied from the master. And all the other files will be rechecksummed on the backup server. And that's actually a multi-threaded process. So yeah, you do have to go back and rechecksum the files. It's not instantaneous, but at the same time, you're not putting load on your master server during that time. So that's a big advantage. Right, so it doesn't put the load to recompress and retransmit the files. Checksumming already compressed files is really, really quick, relatively speaking. Like I said before, everything's done in stream. Compression is never done more than once. If the destination file backup is supposed to be compressed, then the compression is done on the DB master. All the data is transmitted compressed, and then it's stored. So it's not like a situation with rsync where you're compressing, transmitting, uncompressing. If you're on ZFS, you might be recompressing, which adds to performance. But if the destination is uncompressed, then it'll use a lower compression level by default to speed the operation. Okay, a lot of stuff here. Delta Restore. So this is where we get to the really interesting stuff. So what I always tell people is you don't really have to worry that much about how long your backups take. If your weekly full backup is taking less than a day, and your daily incrementals are taking less than a day, and they're not putting significant load on your system, then you're good to go. But when you're restoring, it's a completely different story. A lot of people want an extremely fast restore. If you may be in a situation where the server's gone down. So let's say your backup took 24 hours. You really don't want your restore to take 24 hours. So the good news is you can. There's something called a Delta Restore, and what it will do is it will go and check it'll basically delete anything that's not in the manifest, any files that have changed or the size has changed or things like that, the things that are obviously different. Whatever remains, it'll checksum using the SHA-1 checksums that were stored. So it'll compare file name, file size, and checksum, those 3 data points. If they're not the same, then it'll throw it out and it'll recopy it. This is done multi-threaded. So, and generally speaking, on a system where you're doing a restore, Postgres is shut down, of course, right? You may have multiple clusters on the same machine. But in general, what that means is at that point, you have a lot of system resources to work with. So why not go ahead and use them to do a super, super fast restore? So anything where the checksum doesn't match, BackRest will pull the file from the backup. All right, so archiving. The interesting thing, I didn't really figure this was going to be the biggest problem, the biggest challenge I faced when I started working on BackRest, but it really is. Archiving correctly is really hard. And I think the complexity is continuously downplayed sort of in the Postgres documentation and in the Postgres community. They're like, oh yeah, and write an archive command. And the archive command should do X, Y, and Z. But it turns out to be a really hard problem to do right and do reliably, check for duplicates, make sure that things are actually f-synced, make sure that it plays nice with replicas and that it's high performance and et cetera, et cetera. So a lot of work has gone into the archive commands. So there's dedicated commands for both pushing wall and retrieving wall. So you're not using any kind of rsync or cp command or anything like that. You call BackRest and it does the work. The push command automatically detects wall segments that are pushed multiple times. There's a lot of scenarios where this can happen. So if the segment is actually a duplicate, it just returns success to Postgres and drops it on the floor. If it's different, then it will raise an error, because you should not have the same segment with different checksums. That's a bad thing. Push and get both ensure that they're talking to the right repo. So they actually check the database system ID and version. It's really easy when you're just bringing up a new database server. You copy and paste a configuration from another server, and it's very, very easy to cross the streams on wall and end up dumping wall for two different database clusters in the same directory. Obviously, this is pretty bad, so BackRest will prevent you from doing that.
Do they have to be the same?
Hmm?
Do they have to be the same version?
No, you can have, we have a lot of polyglot environments. So like I said, it actually stores the system ID and the version and actually control number and some other things. So yeah, if you cross the streams on any version, it'll tell you, hey, your database is this, this, and this, and you're trying to push into a repo that's actually this, this, and this. So yeah, mixed versions are definitely supported. We have a lot of environments with mixed versions. Asynchronous archiving allows the compression to be done by another process. So essentially the files are offloaded into a local queue and they're compressed and transmitted in parallel. Now, this particular process has not been parallelized yet because I was waiting until we got off of Perl threads to do it. So parallelization of this process will be coming very soon. So right now it operates in parallel to Postgres, but it's one thread. But that's going to be changing very soon. It'll be multi-threaded up to the level that you specify. But even so, even the way it is right now, this provides quite a bit of extra write volume for large databases, and that'll be getting even better in the future. There's full support for table spaces and links. So you can back up, obviously, table spaces. You can back up databases that use links pretty much anywhere you want. You can, when you're restoring, you can remap table spaces. You can remap links. The default, actually, which is interesting, is so table spaces are kind of a special thing, and those will always be restored as links. That's the way it works. But if you have a database that was backed up with links, and you do a restore, by default, BackRest will restore everything into directories instead. Under pgData. And the reason why it does this is it can be quite dangerous to just start pointing off in random directions on a new server, right? You don't really know what's there. So if you want to restore the links, you do actually have to say, -- link all, or you can do -- link map and just restore certain links and let other ones, devolve back into directories. So there's a lot of flexibility there, but you have to remember that links won't automatically be restored because we consider that to be a little bit dangerous. Another really interesting feature is what we call Selective Restore. This is something that's been requested of me for years, and we implemented this year. So people constantly ask me, can I just restore one database out of a cluster? The answer in the past has always been no. But Stephen Frost and I figured out a way to do it. So what you can do is specify the databases that you want to restore. All the other databases will be restored as sparse zeroed files. So they essentially take up no space. And then you allow wall to replay, right? So what that means is wall will can replay into those other databases. So if you've got a lot of activity on the other databases, you're going to have to use up at least that much space. You can't connect to the non-restored databases. I intentionally zero out a very important file. So if you try to connect to the database, it'll just give you an error and won't allow you to connect. The one thing you can do, though, is drop the database. So once recovery is complete, you can go in, drop the databases you don't want, and you're good to go on the databases that are there. It's a bit of a specialized tool, but for some people, it's extremely important to be able to do this. So,
That could confuse the stupid person.
sorry?
I said that could confuse the stupid person.
Yeah.
Say it's your database.
Yeah, well, the people who love it really love it. It understandably makes some people nervous. We have done a lot of testing of this to verify that this is correct and it works. Which brings us to one of our newest features, backup from standby. Of course, pg-based backup has done this for a long time, but not until 9.6 were the APIs exposed. BackRest still takes a different approach to backup from standby. It doesn't actually copy everything from the standby. The reason for this is that standby backups have some weaknesses. So what it does is it actually starts a backup on the master in a normal way. It waits for the replay location on the standby to match the backup start location on the master. And then what it does is it copies, so what it does is it reduces load on the master. So the whole point of backup from standby is not because you actually want to back up your standby, but because you want to reduce load on the master. So what it does is it copies all the files that are replicated. So the ones that are known to be replicated, everything in base, everything in global, C-log, multi-exact, table spaces, excluding all temp files, of course. And then it copies the remaining files from the master. So what that means is you get a master style backup, which means you'll get statistics from your master instead of from your standby, which is what happens if you do a standby backup. So it's essentially the backup is indistinguishable from a backup that was done from the master, but it reduces load on the master. The other reason we've done this is because, we spent a lot of time on this summer and a lot of time testing this. Doing binary comparisons and making sure that all this worked. And the reason why we went to all that trouble was because we also want to parallelize across multiple standbys. One of the kind of big things about backrest is it's extremely high performance. So there are situations where people want to back up from the whole fleet of standbys, and so this method allows us to do that. It's not supported yet. We wanted to get the feature out rather than extend it indefinitely by putting in too many bells and whistles. But that's the goal, is to allow backup from multiple standbys simultaneously, and this was the way to get there.
What's the issue with doing backups from standby?
Well, there's no particular issue. There's a couple of things that are annoying. So initially we started connecting to the master anyway, because one thing that's annoying is that you don't get a switch, the xlog switched at the end of the backup. So if you want to do that, you have to go do that on the master manually, or you just have to wait maybe indefinitely for the xlog to actually show up in the repository so you can know for sure.
I thought you meant there was a problem with it, but if you're just doing start and stop backup, normally it should be fine, right?
Yeah, no, the backup from standby works. When I say issue, sorry, I didn't mean to say issues as in like the PG-based backup from standby does work, and I have tested the heck out of it, all right? So I feel very comfortable with it. That's not what I meant to say. Sorry, that was a bad phrasing. I just meant that in the kind of ecosystem of dealing with backups and doing backups reliably, and also, like I said, actually getting statistics, say, from your master, things like that. So there are some problems with the way backup from standby works in terms of getting the backups that you want. The backup from standby backups that PG-based backup does are consistent. They are consistent backups of your replica. So, but there are some caveats that go along with that, and that's what I was trying to get away from. Good question, Keith. So real quick, works with 8.3 and above. Here's some performance numbers. These are actually a little bit old. These are,
I was going to ask on the compatibility, how Because you're saying the hooks were only exposed in 9.6 for the
Oh,
pgBase
yeah, actually, sorry.
pgBase backup, so how far does that work?
So backup from standby actually works from version 9.2 on. That was the other advantage of not using the new 9.6 hooks, is that we're able to give have that capability back to 9.2. Technically, it would work with 9.1. The reason why we chose 9.2 is because that's when pgBase backup started supporting backup from replica, and we just wanted to make sure that there wasn't any subtle thing in 9.1 that we weren't missing. So, and we figured it wasn't really that big a sacrifice. So it actually works from 9.2 up. Obviously, backup from standby will not work with 8.3. So yes, different features. Different features work on different versions. One of the nice things about backrest, though, is it abstracts a lot of this kind of stuff. So when you're doing restores and stuff, you don't need to think about which version you're on in terms of how you write recovery.conf or other things like that. It will just figure it out based on your version, and you get a consistent interface. But sure, some features are not available, and you'll be told, it'll just error out. The documentation is a lot clearer about what's available in which version. So I'm going to gloss over this because I really would like to get to the demo. But suffice to say that backrest scales pretty linearly. As it turns out, someone did recently do testing with 64 parallel processes, and it turns out that things did plateau right around, with the Perl threading, they plateaued right around 10. 10 processes was kind of your max.
Is that Perl threading in the parallel program, or is that just the Perl threading library?
The built-in iThreads in Perl, yeah.
Which is what the parallel program is.
That's what all the parallel stuff was based on previously.
That's exactly the number we see too, for just other than database backup. We see exactly the same.
So, okay.
Straight RSAM.
So but now we're using child processes. We haven't, that actual person who did the performance testing is redoing that testing this week. So we're going to see what the results are. I know from my benchmarking that it's slightly faster than the threaded version, but I've only been able to scale it up to about 8 processes. So I just don't have any hardware big enough to scale it beyond that. But he has some serious hardware, and he's going to try it again and see where it goes. All right, so let's do a demo. I think it's always nice to demonstrate how easy this is to work with. Oh, I don't really want this, though. There we go. All right. How is that? Can everyone see, or should I go a little bigger? Anyone? Okay. All right. So here's our demo. I'm really, really afraid of live demos where I actually have to type stuff in because I'm not very good at that. I tend to fat finger a lot of things. So I like to do scripted demos. So this is just a Perl program which is going to go through and run all the commands. So this is running live. It's not a pre-generated demo or anything. So everything you see here is actually running in real time, but just I don't have to type it. So the first thing we do is create a cluster, just for the purpose of this demo. And then we're going to create a basic configuration, which just has the repository path, the DB path, and I've also set retention. And the reason for this is that if you don't have any retention set, backrest is going to throw you a warning at the beginning of your backup. The backup will succeed, but it's going to tell you, hey, if you don't have any kind of retention set, then you're just going to keep using disk space forever, and you will eventually run out. If you find that you actually do just want to have indefinite retention, just set retention full to a really big number. You can set it to 1 billion or something like that. So for all intents and purposes, that's infinite. But otherwise, it's going to give you a warning, just to keep you honest. All right, so let's do our first full backup. So this is it. You just say pgBackRest. You give it the stanza, which is the configuration, for your cluster. There's a reason why we don't call it cluster, because a database ecosystem contains multiple clusters. You can have your master cluster, you can have reporting clusters, you can have replicas, you can have all that kind of stuff. So you should really give the stanza a name that kind of, so don't call it like master. I've called it main here, which is pretty bad. But you really want to have it like app or data warehouse or something like that that describes the group of Postgres clusters that are going to work together. Here we can see, so the backup completed. This is the actual backup directory. So we got the backup that we just took up here. We've got a history file or a history directory where old manifests are stored, so you can go back and do a little data mining. We've got backup.info, which gives you info about the current set of backups. And then there's always this link latest, which links to your latest backup. So that's just a shortcut to get to your latest backup if that's all you're interested in. We can see our backup size went from 53 meg for the database to 5.7 meg for the backup. Obviously, this database is completely empty. You shouldn't expect this compression. But you'll see that when we do differentials, this will start to matter. Oh, and here's our actual archive directory. So not only is the archive file copied over, but it's copied over with the SHA-1 checksum. All of the backup checksums are in the manifest file, but archive doesn't have a manifest, so the checksums are actually attached to the file itself.
So when you do the restore, it strips those off.
Yeah. Actually, Postgres, when you're doing a restore, Postgres wants you to recover, copy it to a file called recovery log. So even it doesn't even preserve the file name. It gets copied to recovery log, and then Postgres does whatever it wants with that, and then it comes back and says, oh, I need this file, 000 whatever, and copy that to recovery log. So that's actually the way that works during recovery. But yeah, that's taken care of by backrest. So now we're going to do a diff backup. Our database has grown a little bit to 69 meg. That's basically one extra wall segment that got created because we switched, rotated a wall segment during our backup. And now we can see our backup size. The size of our repo is 5.9 meg. I think it was 5.7 before. So we only went at 0.2 meg. Why? Because there wasn't a whole lot to copy. PG control, some other minor files. Now here's our archive, so you can see we've done one more backup. And there's another wall log sitting there. All right, so let's do something interesting. So let's say we're going to do a release, right? So you've got a release window scheduled. A good thing to do before a release, depending on what your backup frequency is, but maybe to take a new backup. In this case, we're going to take an incremental. Then when we actually get to release time, we're going to set a restore point. So how many people have used restore points here? Anybody? Okay, cool. So restore points allow you to basically name a point in time. So you can tell Postgres, I'm putting a label here, and if I want to be able to restore back to this point in the future, I can just give you that label. That way you don't have to know the time, you don't have to know the transaction ID, you have this label, you give it, and Postgres is able to play forward from your backup to that exact label. So this is a good thing to do before release, because if something goes horribly, horribly wrong, you want to get back to that point right before the release started. You could certainly do that with a timestamp. That's one way to do that, but that can be confusing sometimes with time zones and other, interesting stuff. So restore points are a great tool for this. Okay, so now we're actually going to do a release. Oh, the other thing I have is I have this little table here, which we're updating to show us kind of where we are. So the previous slide had before release in the table. Now we've gone to after release. Okay, so we've done the release. Now QA tells us the release is no good. They want us to roll back. Now there are two ways to roll back in database land. There are the mythical and often unreliable database rollback scripts, which I don't trust any further than I can throw. And then there is doing point-in-time recovery. So my preference is to actually be fairly optimistic that the release will be successful. And if a release does fail and needs to be rolled back, to use point-in-time recovery to recover rather than trying to run these rollback scripts, which may not be well tested. Also, the thing about rollback scripts is they always assume that your database is the update finished. What if the update didn't finish? You're in the middle of it. Like, how do you figure out what to apply? With this, you don't have to do anything. You just run the rollback. However, this actually did fail because we tried to, sorry. Okay, yeah, there was an error there, and the reason was because Postgres was still running. Backrest isn't going to do anything while Postgres is running. That would be really, really bad. So it'll tell you, it'll error out and say Postgres is running and force you to stop it. So now we've gone and we've stopped the cluster. We run recovery again, You can see we're doing a -- delta restore up there. The other thing that -- does is it will automatically write your recovery.conf file for you. Based on the information it has, you gave it a target name that you want to restore to. Obviously, it knows how to write the restore command because that's also -- So that's automated. You don't have to do it. If you want to write your own, it's fine. You can tell -- preserve the one that's in place, and it won't mess with your recovery.conf. But for most people in most situations, letting -- write the recovery.conf is the way to go. So now we can start the database, and we can go and check and see where we are, and it says we are before the release. So yay. The other thing we can see is that in the archive, we have moved on to a new timeline. So now we're on timeline 2. So anyone dealt with timelines at all? Anyone have a database that's not on timeline 1? Okay, yeah. So this is kind of interesting. So what we've done is Postgres has created this new timeline because there's WAL from the original database, right? That's on timeline 1, and that's where we actually did the release. Well, now we've split off into kind of an alternate reality where the release never happened. And so Postgres creates a new timeline, and then it starts playing forward on timeline 2. 2 reasons for this. One, so that you don't overwrite old WAL, right? You can't just create WAL records in the same logical serial number. That would be bad. So here we've created a new timeline, and we've gone off on that new timeline. So this is the new reality where we've rolled back the release, and now we're sitting back before the release again. All right, so now the app is started, and important data is written in the database. So we're going to signify that with our very important update here. And so now QA tells us, okay, so this is a little bit contrived here, but bear with me. So now QA has told us they made a mistake, the release is good. They want us to undo our rollback, i.e. they want us to go back to, rather than doing the whole release again, which could take 6 hours, they want us just to restore the database to that timeline where the release had been done. So we can do that. We actually, in this case, all we have to do is a restore. And the reason is our backup is on timeline 1, and Postgres will always want to follow the timeline of the backup. So now we get back to the point, you can see the message here, we're after the release, and everyone's happy. Well, not quite. Because remember that very important data we wrote? Well, now that's gone. And we really, really need to get that back. So where was that? That was on timeline 2, right? So we're actually on timeline 3 now because we recovered timeline 1. That switches us to 3. But that very important customer data got written on timeline 2. So we can actually tell -- and I would be doing this on a, not on the production server anymore, but on some test server, some QA server or something. We can actually tell it to restore to timeline 2 instead. And when we do that, we get back to our very important update. And voila, we can recover our data. So it's a little bit crazy, and it takes some time to get used to, but once you're really used to how timelines work, there's a lot of incredibly powerful stuff you can do. And also, you can free yourself from, like I said, having to deal with these rollback scripts and all these other things by having a very reliable, reproducible process that will get you to the same result, or better result, hopefully.
Very important update is on the offline.
Sorry?
Your demo here, very important update is on the
Offline.
Yeah, you said.
Yeah, well, the idea was we restored the master database to, back to after the release. That's when we realized we had written some important data in that we needed. So this was the sort of thing I was talking about early on where you can use -- for forensics, like to go back and get old data that was accidentally deleted. So you'd want to do this offline someplace probably. That's the way I would handle it. Otherwise, you get your master database back here. I guess you could reapply the update. It'd be your choice, right? You have to decide what's easier. Do you put your master database back here and then reapply the entire release process? Or do you manually reapply this data on top of the release database? So that's a decision you would have to make as an administrator. This is just to show you the info command. So from the command line, you can ask for info, and -- will give you a status of all of your backups. And it'll also do it in JSON format. So if you want to automate things, put in monitoring, have this communicate with your application or do anything like that, you basically get a complete dump of everything -- knows about the repository in a JSON format. Okay, so that is actually the end of the demo. All right, so that's all I got. Are there any questions? Sure. Okay, so the question was, does backrest handle encryption? The answer is currently no. It is something that we are thinking about, and we'll be implementing before we say put in S3 or some other services like that, because it'd be pretty important. Right now, most people are backing up within the enterprise, and so they can live with not having encryption. But yeah, so it's definitely something we're thinking about, but it's not something we've actually implemented yet. Yes?
Are there any other dream features that you'd like to see added?
Well, the main thing that we're thinking about in the near future is parallel archive push and get. There's some people out there who are having problems with big queues building up and other things like that. So those are the next couple of things coming down the line. We're very interested in integration with pgxlog receive, for instance. Yes?
Is it also possible to interact with storage managers like the Steele or backup directly to tape?
Not yet. What we're looking at is a way to, the nice thing about having your own protocol layer and doing sort of everything yourself is it does ultimately make things extremely flexible. So what we haven't done is made the storage manager completely pluggable yet. So what I'd like to do is get that and the compression code nicely separated out so that we can provide a couple of different storage managers and obviously give you the opportunity to write your own. Yes?
If you're doing SHAs on data for integrity, do you have any customers ask about doing Merkle tree type construction where you can provably audit the system? Like in other words, just chain all of the, like a Bitcoin or something where you actually have a beginning and ending seed that describes the whole backup process.
Not yet. We kind of have that. What we have is we have the manifest itself, which stores all the checksums, is also checksummed. Right. So we have two-layer verification. So
the idea is you could present a starting and ending chassis that describes the whole process, right?
yeah.
And they say, okay, here I'm here, and each here is the starting and ending chassis like a Bitcoin audit.
Right.
When you're already doing the expensive part.
Yeah.
The
Shawing the SHAs is
right.
extremely simple and easy, of course. This is something we've actually talked about just in relation to additional integrity checks. Yes, and making sure that we can just show. Some people don't. Even though the possibility of a collision with SHA is so low, some people are still skeptical. So we've been looking at some additional checks to put on top.
You SHA-3, but my point is just you got a beginning and ending seed.
Right.
That finds a very complex data structure trivially, and you just say here's this backup.
Right.
Started here, we end here.
Right.
Everything in between, just follow the Merkle tree.
Is in between. Yeah. The only problem with that is that you can definitely do that. Like I said, I wanted to keep the backup structure and the backup format as simple as possible. There are theoretically optimizations you could do to storage and stuff if you were to go to that kind of a technique. But I've been trying to keep things simple and understandable so that people can.
Hospitals get audited a lot. If you had something like a SHA Merkle tree, you could formalize the audit.
Okay. I'd actually be interested in talking to you about that. But I think we are out of time. So any further? Yes? I'm sorry, I'm not quite.
How do you have like a catalog to view backups?
Yeah, there's no way to create sort of an external catalog. There is a catalog kept in backup info and backup history. But actually, someone has actually done this externally, and we're hoping maybe to bring some of that code in. But no, there's no externally accessible backup catalog at this point, other than calling the info function and getting the big dump of the JSON blob. Okay, well, I think that's all of our time. So thank you very much, everybody.